Hey everyone. So in this video, we're going to understand what a one-hot encoding of data labels means. So let's take an example. Let's say you have this image, right? You have this image of this dog here, and you have what this represents is the image in pixels, right? And let's say you have a neural network, and the goal of the neural network is to try and predict what this image is actually telling. So the neural network does not know it's the picture of a dog, and what the neural network has to do is identify whether it's a picture of a dog, a cat, or a rabbit, right? So it's basically a classification problem, right? An image classification. How would you set about training the neural network? Well, you take a data set full of images, and the images would be images of dogs, cats, and rabbits, right? Different kinds of dogs, cats, and rabbits. And what you'd then do is feed it through the neural network, and you'd have the corresponding label, right? So it would be dog, cat, and so on. Problem is, how do you explain to the neural network what the label is, right? It does not understand text. So you have to convert this label, which is text here, into numbers. So what would you do? Well, a simple, idea would be, let's say dog is 1, we can say cat is 2, and rabbit is 3. And now all of a sudden, you know, you know what you can feed the neural network, right? In terms of training it. So this approach is called a label encoding, right? You're taking the label and you're encoding it, converting it into a number. And so what would happen? Your input would be the image, the pixels of the image, right? Which are numbers. And then what you would have is the label, which instead of saying dog, you'd say 1. And then you'd say 2 here. And for the rabbit, you'd say 3, and so on. And now what you could do is effectively your problem becomes training the neural network such that it outputs 1, 2, or 3, depending on the class, right? Or it outputs something else, but then effectively the label you're going to provide it is 1, 2, and 3. The problem here, as you can imagine, is with normal numbers, there is a hierarchy associated with numbers, right? So 2 is greater than 1, 3 is greater than 2, and so on. So how do you explain to the neural network that these are actually just labels? They don't really have a meaning, right? It does not mean that the cat is greater than the dog, for example. So one issue that shows up with this, which can affect the training, is kind of when you use just normal encoding. And so the solution to that is to use a one-hot encoding. And so let's just look at how you do that first, and then I'll explain, what or how we've got here. What we can say is, well, what if dog is represented, instead of saying 1, is represented by this vector, which is 1, 0, 0, right? And let's say cat, if you're saying cat, then actually you would actually write the label as 0, 1, 0. And for rabbit, it would be 0, 0, 1. So what we've done here is we said, well, first of all, we're replacing this text label with a vector. The size of the vector, meaning the number of elements in this vector, is equal to the number of categories. There are 3 categories, so the size of this vector is 3. And effectively, what each element in this vector, so the first element in the vector is basically, kind of toggled or set to 1 if the label is dog, right? All the others are set to 0, right? So this, which is set to 1, is called the hot value. It's the active label, right? And the others are 0. The second is for cat. So if it's not a cat, it's set to 0. If it's a cat, it's set to 1. And similarly, the third indicates rabbit, right? So if the label is rabbit, then the label is set, then the vector is set to 1. So this is basically, by the way, this is not a prediction, right? This is basically the label which is telling you what the image represents. This is the actual answer, right, to the data. And you're just replacing this with a vector, right, which effectively is telling the system, the computer, the neural network, or the training model exactly the same thing, only it's representing this in this form, right? So each vector dimension actually represents the class, right, that it belongs to. And only one is set to 1. Only one value in that vector is set to 1, the others are set to 0. The thing set to 1 is the active value. So let's now go and take the images we had, but now replace the labels with the one-hot encoding. So in this case, we know it's a dog. This is the actual data we're training on. So the labels are correct. So they need to be correct. So it'll be 100, right? One is for the dog. If it's a cat, it's 010. The rabbit, it's 001. So we have a cat again, so it's 010. We then have a rabbit, 001, and then a dog, 100. So we've seen how now we can replace the labels with these vectors. Now, apart from the fact that it takes away this issue of hierarchy, right? There's another advantage of using the one-hot encoding, right? Typically, when you use a neural network for classification, you would have at the end you would have a softmax layer, which would take the logits from the last hidden layer. So typically for classification, in this case, you would have a convolutional network, but then you would have a linear layer, right? You could have an activation function to that, but typically you have a linear layer, which then gives you the logits. And then you'd add a softmax, right? Which would then convert the logits into a probability. So you'd end up with, in this case, say it's a dog. Let's say our network is able to say zero point 0.6, it's a dog, 0.25, it's a cat, and 0.15, which you can think of as percentages, right? 60% it's a dog, 25% it's a cat, and 15% it's a rabbit. Okay? And now if you have the one-hot encoding now as of the label, well, what is it telling you? It's telling you the actual answer is 100% it's a dog, 0% cat, and 0% rabbit, right? Because you know the answer to the question. So now what you can do is you can use the cross entropy loss function, right? And I'll add links to both the softmax and the cross entropy, and how what they are and how they work. But effectively, you now have an ability to compute the loss of this neural network by comparing these two probability distributions. They can be treated as probability distributions. This one-hot encoding can be treated as a probability distribution where you're saying you actually know this is one and the other is zero. So it's a 100% chance of it being the class. So if this was a cat, it would be 010, right? For example. And you can use this to train the network. Okay, so we've seen how you do a one-hot encoding for the label and how it works and why it's important, right? Now, you can also do a one-hot encoding, and in fact, you should do a one-hot encoding, not just for the label, but also for features, which is the input vector, right? In that case, it was an image, and so it was just, the pixels. In this case, let's take a different example. Let's say you have this data set, that you're going to run a machine learning or a deep learning model on. And what is this data set? Well, it's a product list of products, clearly, clothing, and what you're trying to do is predict if the product is going to be a top seller or not. Let's say a top seller is the top 10 selling products for that company. Okay? What you're trying to do is you have this data and you're trying to see if the model can predict accurately if the product will sell or not, right? So it's an interesting kind of predictive machine learning or neural network model, for marketing, let's say, or for forecasting. So price is fine, it's a number. Likes on social media for that product is fine. But now you have the type of product. So let's say you have jeans, t-shirts, and hats, right? Now that is a categorical variable, kind of like a label that we had, only here, it's the input coming into the neural network. So again, you can't give the neural network the text. You can't tell it, well, t-shirt, jeans, or hat. So again, the choice would be to replace it with 1 for t-shirt, 2 for jeans, and 3 for hat. But again, you have the problem of, does it really mean anything? By saying that, will the neural network get confused and think the hat is greater than the jeans, for example? So instead, what you do is one-hot encoding, right? So let's say the first class is the t-shirt, the second is the jeans, and the third is the hat. So if it's a t-shirt, it would be 100. If it's the jeans, it would be 010. And if it's the hat, it would be 001, right? Pretty much like we did before, only there it was for cat, dog, cat, and rabbit, right? But now you have a one-hot encoding for the category, in this case, what kind of clothing or what type of clothing it is. And so what would happen now is the input feature called clothing type or type, which was this, would get replaced by 3 input features. It would be t-shirt, jeans, or hat. So effectively saying, is it a t-shirt, is it a jeans, or is it a hat? If it's a t-shirt, it cannot be a jeans. If it's a jeans, it cannot be a hat or a t-shirt, and so on, right? We know that. So they're all exclusive. And so in this case, the label says t-shirt, so you'd say 100. If it's jeans, you'd say 010, and so on. You'd make it a one-hot encoding, but now each element or category in that one hot encoding is now an input feature that goes into the machine learning model or neural net. So in this case, now your input feature would then now be product, whatever it is. But now you have the t-shirt, jeans, and hat. The product is not the input, right? These are the inputs. This is just the type of thing it is. So you'd say t-shirt, jeans, or hat, right? And then you'd have the price and the likes. And the output, the label is whether it's a top seller or not. So we've seen how now it's not just for the output label, right, that you'd convert or you could convert into a one-hot encoding. If you had an input feature that was categorical, you would then convert that into a one-hot encoding as well. And so you'd end up replacing, in this case, one feature, which was a text feature telling you the type of apparel, with three input features, which are effectively the one-hot encoding, telling you whether it's a t-shirt, a jeans, or a hat. So hopefully this has given you a very good understanding of what a one-hot encoding is, and how they can be applied and how they should be applied to kind of convert categorical variables, whether they're the label that is used to train the network or that's the input feature, right, into this vector form so that it can be fed into a machine learning model or a neural network, right, and kind of help improve the training process. So hopefully you've understood this well. See you in the next one.